Okay, I thought we would start today. The people in class have just been returned their test. And I thought about ahead of time whether or not we should do this in the cable class as well as this being put on video after this semester. But I think there's a lot of times things to be learned from mistakes made on tests. And having graded them, I really feel like I need to address some areas that if we really do have misunderstanding kind of in general, which I feel like I maybe haven't done my job in that regard, let me try at least to clear up or clean up some areas where I think we need to have a better understanding before we go on into this stuff called calculus. So I'm going to go through test items. Let me point out also that if you have your book handy, I don't know how much you realize that I actually took this test from the book. But let me point this out. As I went through the review, which I told you I was going to do, there were a lot of good problems there. And I said, gosh, I like those better than ones that I think I could make up. So if you look at page 85, if you've got your book, you might develop a strategy here to study for the next test. Look at problem 5. Does that look familiar? That's problem 1 on the test. Problem 9 ought to look reasonably familiar. Problem 17 ought to look pretty good. Problem 19, I took parts of 19, but basically it's the same problem as 19. Problem 22, there's our toaster and cost of production problem. 24, find the inverse of a function. 27, find the half-life of that. There it is. There's your test right there in the review. So it's not like, and problem 31. Sorry, there's our parametric equations. So I felt like those were kind of middle-of-the-road questions. I realized the test was too long, and I'd graded them all out of 12, and then took your worst problem, and hopefully I crossed out the number of your worst problem. If I failed to do that, then hand me your test back, and I'll retally your points. But I think I went back through and put a big X through the problem of yours that I did not count. Let me have that at the end of class if that's not the case. But these are kind of problems that are certainly in the text, I think middle-of-the-road problems. Let's go through some of these. I gave you a solution sheet today, but there are some things that I want to go through in more detail than what I was able to write on the solution sheet. For example, the first question. I think we ought to be really, really well-versed on domain and range. And the use of your graphing calculator, if you want to incorporate that. But remember that we've got to be able to not just rely on that picture, because sometimes it might look like the domain goes from -1 to 1. Well, actually it was approximately -1.15 to +1.15 because it was a decimal approximation of an irrational number. But if you see just this piece of the problem right here ought to be some indicators to you that there are some ways that we're going to have to restrict the domain. If we have the square root or fourth root or sixth root or any even root of a quantity, what do we have to make sure is true?
No zeros under the bracket.
Okay, it's okay to have 0. The square root of 0 is 0, but we can't have negatives, not if we're going to deal with real values. So before I even write it down, I'm kind of thinking whatever it is that I write down, has got to be greater than or equal to 0, right? Everybody all right with that? And so we're talking about the domain now. Now, also when I look at this and write it down, I see that the y values are what? They're principal square roots. What are principal square roots? 0 and larger. So I already know, without any further investigation, that I'm not going to have any negative y's. Y's are greater than 0, or equal to 0 at this point. since I have the difference of things that are squared, and I know 3 is not a delightful number to work with, but I can write that in factored form as the sum and difference of the square roots of the things that are being subtracted, some a squared minus b squared. And I don't know if you're used to this process, but kind of find the values that make this equal to 0 and then use test values from there. So if I find this one, there's one of my values, 2 over the square root of 3. And there's the other one. So if you just used your graphing calculator and you got roughly from -1 to 1, that's these values. And now on a number line, is this a process that you've done before? Find the so-called critical numbers, which in this case are -2 over the square root of 3 and +2 over the square root of 3. Do we want them to be part of the solution set, by the way? Are they included in our final domain or excluded? Included, because it's okay to have them equal to 0, greater than or equal to 0. And then just try some points. Is this a process you've used before? Kind of sampling? Test values, I think they call it sometimes in a textbook. So we could try a value left of -2 over the square root of 3. You'll see that that makes this term too large, which makes this negative. We don't want that. You can try a value in here. Very conveniently, 0 is in there. 0 happens to work in this, right? So we want all of these. And then you can try a point to the right of 2 over the square root of 3. And again, that causes what's under the radical to be negative. So there's our domain. And we had a variety of ways of finding the range. I could tell by the little sketch that some of you made that you had probably put this into the graphing calculator and gotten a picture of it to see what are the largest values and smallest values for y. Well, we know the smallest value is 0, right? Because it's the principal square root of something. And you say, well, what is the way I could make this the largest? So I'm 4 minus 3x squared. When would 3x squared, this stuff that I'm subtracting, when would it be its smallest? When x is 0, right? So 4 minus 0 is 4. Square root of 4 is 2. That's the largest y value you're going to get, is 2. So our y's, you can kind of think of it that way. That's not the way I did it, but I could tell by some things you had written down that a couple of you went through that thought process. Here's the way I went after finding the range. I knew it was greater than or equal to 0, just because it's a principal square root. I squared both sides. Of course, I know that I'm changing the problem now when I square both sides, but I can go back to my original set. It's the principal square root. Bring that 3x squared over here. What's that looking like at this point? Which is also some of the stuff we reviewed.
An ellipse?
That's an ellipse, isn't it? The sum of the squared terms, but we have different coefficients. So we know it's not a circle. The circle would have the same x squared coefficient as the y squared coefficient. So we could come down here. This isn't absolutely necessary, but if you're trying to get a picture of kind of a maximum, a highest y value for the range, this becomes x squared over 4/3. which is, we've already dealt with that. Y squared over 4. So there's kind of the standard form of an ellipse. And this ought to tell us on the y-axis how far up we go, right? This would be our either a squared or b squared value. So we come out here to positive and negative 2 over the square root of 3. You can see those values. We've already got them, so we don't really need that piece, but we do need this piece, is that we're coming up here 2 units. So we've got the positive portion, positive half ellipse, if you want to call it that. So here's our domain, negative 2 over the square root of 3, up to and including 2 over the square root of 3, and here's our range, 0 to 2 inclusive. So use that graphing calculator on that one too, because that can be helpful. Everybody did really well on problem 2. I don't see an issue there in common to talk about. Even, odd, or neither. This is one of the things that unfortunately took some time, more time I think than I originally realized. But if you can show that the f of x is equal to the f of negative x, that's the way to show that a function is what?
Odd.
Even, right? So it doesn't matter if you put in a positive x or a negative x, you get the same y value. So that's an even function. And what kind of symmetry do even functions have? Symmetry with respect to the y-axis, right? So as an example, let's just take one that is even. Question?
So on the test solutions, you wrote like f of x is equal to f of negative x is not even. It's odd.
Yeah, in other words, if that didn't work on the problem, then if it was not even, then I went ahead and checked to see if it was odd as well.
All right.
Okay? So if that were not true, then I said it's not even. Let's get both of these here. If the f of negative x is the negative of the f of x, then it's odd. And some of you were basing your answer on symmetry, which is fine as long as you know what kind of symmetry is created. Symmetry to the origin, right? If it's an odd function. So let me go back and do what I said I was going to do. Let's take one that was in fact even. This was even. E to the negative x squared. Well, the x squared even power ought to give you a clue that it's an even function. But is the f of x equal to the f of negative x? Well, the f of x is the way it was handed to us. And the f of negative x says that I'm going to put a negative x wherever there's an x and do to negative x what was done to x. So if I square negative x, isn't that the same thing as x squared? Right? So left side and right side are the same, so that is an even function. And if we sketch that, we should expect to get symmetry with respect to the y-axis. Let's get one that is odd. How about the second one there? The indicator there is that both exponents are odd. So is the f of negative x, is that the same as the negative of the f of x? Well, the f of negative x is negative x cubed minus negative x to the 7th. Is that equal to the negative of the original function? It is, isn't it? Right? When you cube a negative x, don't you get the negative of x cubed? And when you raise a negative x to the 7th, you get the negative of x to the 7th? So that little operation right there tells us that that's an odd function. And if we sketched it, we should expect to get symmetry with respect to the origin. Okay, and one that's neither. Let's take 1 plus sine of x. Now, if this were sine of x by itself, what is the sign? Is that even or odd? It's odd, right? Sine has symmetry with respect to the origin, does not have symmetry with respect to the y-axis. Is it even? So is the f of negative x the same as the f of x? One plus sine of negative x, is that the same as 1 plus sine of x? Well, the sine of negative x is the same thing as negative sine of x. Those are not the same. And is it odd? Then the f of negative x should be the negative of the f of x. F of negative x, is that the same as the negative of the f of x? Those are not the same. This is 1 minus sine of x. This is minus 1 minus the sine of x. Not the same. So it's not odd, but neither is it even. The composition of functions, everybody did well with the composition and not necessarily so wonderfully with the domains of the composed functions. Let's look at the domains. So the f of the g should be, means we square x and subtract 9 first, and then we throw it into the natural log function. There's the f of the g, right? Now, when you're talking about the domain of this, what kind of things can we take the natural log of? Can you take the natural log of a negative number? Can this be negative?
No.
Nope. Can it be 0? Can't even be 0, right? Doesn't it have to be positive? So x squared minus 9 has got to be greater than 0. I'd probably go about that the same way I did just a few minutes ago, and then do some test values and see which set we want. Well, we know we don't want negative 3 and 3, because they would make it 0, and we don't want it to be 0. We can't take the natural log of 0. And it turns out, what set do we want here? I think we want this set. We don't want these. And we want that set. I believe that's right, isn't it? We want x, when we square it, to be larger than 9. So that would happen over here and also over here. So there's the domain for that function. The other composition, the g of the f, says we're going to take the natural log of x first, then square it and subtract 9. So there's the composition the other direction. Okay, how do you analyze the domain here? I think domains was a key issue that I want to make sure we know better before we go further. Can you square anything? Yeah, you can square anything, but we could first of all have to do what with it? We have to take the natural log of it first before we square it. What can you take the natural log of? Something greater than 0. So x has to be greater than 0. Then we take the natural log of it, then we square it, and we can subtract 9. We can do all that stuff. But you've got to be able to take the natural log of it first, prior to squaring it. Inverse, everybody did wonderfully. Half-life, I don't see a problem there. Let's go down to the conic sections and do that, and then we'll see what kind of questions you have from the first 3 sections of Chapter 2. (4x² plus 8x minus y plus 7). Now, some of you just wrote down parabola when you looked at this, I would imagine. So how did you know that was a parabola?
You take y onto the other side.
Okay. You moved y to one side and left everything else on the other. You've got y as a function of x, and it's a quadratic function, right, which we recognize as a parabola that opens up. And there are a variety of ways here to find the vertex and kind of go from here, but I think you ought to be prepared to do this, something like this. I want to try to put it in what's a so-called standard form, where I can pick off the vertex and kind of go from there. So I factor a 4 out of the x terms, and I left space to complete the square. What completes the square in x? Plus 1? Okay, now pay attention to what I do here. What did I just do to the right side? Just added 4, right? By putting 1 in parentheses, it was multiplied by 4, so really I just added 4 to the right side. I better also subtract 4. Or I've changed the problem. I can't just, put a number in on one side and not compensate for what I just did. So this becomes and there I think the vertex is pretty clearly visible, because doesn't this mean what? Left 1 and up 3, right? From a parabola that has its vertex at the origin. So the vertex is -1, 3. And it opens up from there, right? And I think I said sketch. Yes, and sketch. Actually, it's pretty skinny parabola, right? Because of the 4. This 4 says the y values go up further, or quicker than they would normally, because we're going to multiply that thing by 4. It causes them to go up more rapidly. Questions on that before I move that one? The ellipse, which that was one of my questions here. Guess I ruined that question.
I had a question.
Okay.
What would the directrix have been for that one?
What is the coefficient? 4 times p, right? Or 1 over 4p. So that would mean we'd go 1/16th of a unit the other direction from the vertex. So whatever that horizontal line is. Now I felt like that kind of question was a little bit over the top. That's why I didn't go beyond like find the focus and find the directrix or find the foci of the ellipse. I felt like we hadn't spent enough time on that. So that would have been a little unfair question. All right, back to the question that I answered myself a minute ago. How do you know it's an ellipse?
Different coefficients.
Okay, different coefficients. So we've got 9,
Square and y.
Yeah.
we've got x squared plus y squared, right? So we've got both squared terms present. they're added, that means it's an ellipse or possibly a circle, which is a special ellipse, and the coefficients are different, 9 and 16, which means it's got different axes, a different major and minor axis. So that's how I would set up the first step of getting this into a more standard form. There was a y there, right? What is that? 6? Yes.
Mhm.
So all I did was factor out the coefficient of x squared for the x terms and the coefficient of y squared from the y terms. What completes the square in x? Plus 4? What did I just do to the left side? Added 36. I better do that over here. So now a little bit different this time. I added the same thing to both sides of the equation. What completes the square in y?
9.
Plus 9. What did I just do to the left side?
Added 140.
Added 144. I better add 144 over here. And then divide everything by 144. That's a standard form of an ellipse. So the major axis would be on, or in this case, parallel to the x-axis. The minor axis would be on, or in this case, parallel to the y-axis. Umar.
How did you get 4 and 9 third step?
How did I get?
4 and 9.
Complete the square.
Yeah.
Okay, how did we actually come up with that number? Take half of this coefficient and square it, and that'll make that trinomial a perfect binomial square. Take half of this coefficient and square it, and that'll take that, make that trinomial a perfect square. So where's the center of this thing? 2, -3, is that right? Major axis is not on the x-axis but parallel, so we'd come out here 4. Minor axis parallel to the y-axis, and so that's a squared, so a is 4. This is b squared, so b is 3. And basically there's where the ellipse is in the plane. Not a fair question? That's up for debate, I guess. If you got it right, you're thinking, oh, that was a great question. And if you didn't get it right, you're thinking, man, that guy's a jerk. I can't believe he asked that one. So you're both right. Any other items you feel like something was graded too harshly and you want to appeal it, you can do that. I do reserve the right to, on an appeal, take off more points than I took off the first time if I feel like it's a frivolous appeal. So if you didn't do anything and you lost all 12 points and you felt like, gosh, I'm a pretty good person and, you know, I wear deodorant and, you know, that deserves a couple points or something. But I'll reserve the right to take off more points on an appeal if it's frivolous. Now, have I ever done that? I have never done that. Never, ever had to do that. But I always say that so I don't get a bunch of frivolous appeals. If the points are not added properly, certainly we can get that figured out right at the end of class. Okay, any issues with the test? Let's file that away and let's dig back into chapter 2. We are where we should be according to the syllabus, so let's see if you've got questions on homework that we can clear up before we advance. Somebody watching on the TV course or somebody later on the video course, you may have a question too. So I think this is a valid thing to do at this point in time before we move ahead. Let me just see. Let's take them by sections here. Now I'm making an assumption, maybe not a good one, that we're okay to deal only at this point in time with chapter 2. Is that a valid assumption? Anybody has I don't see any problem with that, but if anybody has a question over anything from chapter 1, you can see me and we can work on that. But let's start with section 2, or chapter 2, section 1. Anything that was assigned to you there that you feel like if you saw it again, you would have liked to have asked about it in class? Not that I would ever take problems from the book and put them on a test. That would probably never happen.
Number 2.
Number 2. Let's see. Now, what were we talking about? The tangent and velocity problem. So I think we're talking about slopes, average rate of change, going over to instantaneous rate of change. Number 2, page 99. A cardiac monitor is used to measure the heart rate of a patient after surgery. It compiles the number of heartbeats after T minutes. When the data in the table are graphed, the slope of the tangent line represents the heart rate in beats per minute. At that instant, right? So if it's a tangent line, it would tell us exactly what's going on at that very instant. The monitor estimates this value by calculating the slope of a secant line. Use the data to estimate the patient's heart rate after 42 minutes using the secant line between the points with the given values of T. So it looks like we're going to do the same thing several times over. Let's do what they want first. So we want the slope of the secant. So an average rate of change, and we want to go this time from our initial time 36, to an ending time of 42. Now, will that tell us, let me read this question. Use the data to estimate the patient's heart rate after 42 minutes. Now, we're not really finding out what's going on at the 42-minute mark. Aren't we really going from the 36-minute mark to the 42-minute mark and finding an average rate of change? That's what we're doing. So we'll see how good of an estimate this is. Okay, so where are we? At T equals 36, what are the heartbeats? 2530. And at time 42, so do we have the choice when we're given an ordered pair? This came up on the test too, because we had the cost of building toasters or whatever it was. You have the choice when you have an ordered pair. Can you flip-flop ordered pairs? And I mean, is there anything that says this has to be first and this has to be second? Nothing that says that. So something in the problem has got to tell us which one we want to put first. So what is it here? I think it's the tangent line represents the heart rate in beats per minute, right? Isn't that what we want? We want beats per minute. So if we're going to align things with what we normally have occupying the first position in the second position, what do we want? Where? Do we want 36, 25, 30 or 25, 30, 36? What do we, if we're finding a slope? Excuse me, slope is typically, if we have x's and y's, what's slope? It's usually the difference of the second elements, right? Minus the difference of the first elements. So we want the second elements to be what? Beats? What is this, minutes? So let's take the difference of the second elements. Excuse me. Now, are we sure that I have beats in the numerator and minutes in the denominator? Right? And I've subtracted them in the proper order? Excuse me, I'm sorry. Rest is arithmetic, right? 418 over 6. And we probably wouldn't leave it 418 divided by 6.
69.7.
69.7.
0.7. Yep.
Now, is that, do you trust that to tell us what's going on at the 42-minute mark? That's over a 6-minute interval, right? So that may or may not be what's going on at the 42-minute mark. Sorry. Do we need to continue with that problem? The rest of the problem says from time 38 to 42. Do you think that'd be better? Is that a little closer to what's going on at the 42-minute mark? Probably. C and D are between 40 and 42. That's probably pretty good. How about D, 42 and 44? That's probably pretty good. In fact, what could you do with C and D to get a pretty good idea what's going on at the 42-minute mark? Average them, right? Are we okay to leave this one? Is the rest of this one okay?
What was the conclusion?
Yeah, that's the part.
Final conclusion.
I think they wanted something like the
Did it peak
heart
at
rate
40?
increases or something.
Let's see, how do they phrase the question? Use the data to estimate the patient's heart rate after 42 minutes using the secant line between the... So we're just using different values. If they said find the... what do you think are your best two estimates? Well, I would clearly go with C and D. And if they said, suppose you wanted to use this data to be even closer, excuse me, I would say average the answer to C with the answer to D, and that would tell you what's going on very, very closely to what's going on at the 42-minute mark. So I guess there is no real conclusion per se, is other than that we think C and D probably do the best job. And if we had to conclude even further, let's average part C and part D, and I think we'll have an even better answer. Anything else from that list? Yes, Lisa, right?
This is really simple, but on number 3, I'm getting the answer in the back of the book for C. It's when it does the equation of the line. It's not what I'm getting, and I'm using the point slope formula. I don't understand.
Okay, and you feel like, though, you were right to that point?
Yeah, I understand how they got the 1/4 for the slope. I mean, I estimated all the slopes.
Okay.
But if 1/4 is the slope and the point is 1 1/2, how
Right.
is that?
Let's see. So
I mean, I know
everybody look at your answer to 3, and see if make sure we're putting in the right information. So we're trying to not do A and B, but yet get the answers to A and B, because the question's on part C. Guess the value of the slope at the point 1, 1/2.
Well, yeah, it's part C.
So are we okay? Can we get a consensus 1/4? Right? That'll give me a pretty good indication who did this homework problem, what kind of consensus we actually didn't get on that one. And part C ought to be y minus the known y value equals slope x minus the known x. So y minus the known y value is slope x minus the known x value. I don't have a problem with if I ask you to find the equation of a tangent line and you get to that point on a test, you can actually leave it there. I know you know what you're doing if you get to that point. Is that the...
No, the answer that's the part that's what I got, but the answer in the book is y equals 1/4 x plus 1/4.
Okay, and that's what it is, right?
Yeah.
Isn't that it?
Mm-hmm.
Minus 1/4 plus 1/2 would be plus 1/4.
Okay, maybe that's fine. Okay.
Those old fractions, doggone them.
He uses them.
Okay.
I think we're okay. You're doing it
All
right.
right. Well, I actually did it wrong.
Anything else from 2.1?
What about 8B?
8B.
Yes, instantaneous velocity.
Use the graph. Well, that opens itself up for a variety of answers. You'd have to have a pretty accurate picture. Here's what I think they want you to do on that one. What page is this? 100? Use the graph of s as a function of t to estimate the instantaneous velocity. So we've got a distance, or what is it, position versus time function. And we want the instantaneous velocity at time 2. So we would plot these points as accurately as we can. 110. That right here, 232, and then you would get this curve, whatever the curve looks like, and then they want you to come up here with a straight edge, some kind of a, to this right here, at t equal 2, come up here, draw in the tangent line. Hopefully your graph is a whole lot better than mine. It needs to be much more accurate than this if we're going to use the graph to get the slope of the tangent and then figure out the slope of that line using, grid on a graph paper, counting spaces, measuring, whatever. Not a great way of getting the slope of the tangent. It is if you've graphed it real accurately and you have some real accurate graph paper, but you'd probably want to go about it a different way. I would probably go about it if I didn't use the graph. I would probably use 110 and 232, get the slope of the line segment that connects those two, and then I would probably take 232 and 370, get the slope of the line segment that contains those two, and then do what?
Average them.
Average it. That's probably what I would do, but that's not really what they say to do. They say to use the graph. I would trust my arithmetic calculations a lot better than I would trust my graphing and, reading things off of a graph. But if I were calculating rather than counting spaces, I would probably go about it this way. Anything else? 2.1. We can get a question, maybe, on 2.2. Anything that we don't get to today, as we have time, we can get to those things. Looking at page 108, 109, section 2.2, limits. Pardon? 18. Now, is this, somebody asked about 18 the other day?
Yeah, I did.
You did, okay. Now you're asking again, gosh. Well, I'm sorry, we're out of time today. We're not going to be able to do it now. Let's do 18. Page 110. All right, let's see what this says. The slope of the tangent line to the graph of the exponential function. Why in the world would I pick that one out? Y equals 2 to the x. At the point 0, 1 is such and such. Estimate the slope to 3 decimal places. So the limit as x approaches 0, 2 to the x minus 1 over x. Well, now we've done some limit. I mean, this was our, I think, kind of our first day with limits. We've also done some other things with limits yesterday in class. But we want to figure out what's going on at the point 0, 1. Estimate the slope to 3 decimal places. How are we going to do that? How are we going to take this given limit and estimate? That is the, what do they call it? The slope of the tangent line at the point 0, 1 is that. So I guess we take some values, right? Reasonably close to 0 and see what happens, right? Any value that you care to start with that is fairly small? Okay, let's start with 0.1. That may be a little too small. So we're supposed to let x approach 0, according to this. Let's start off with x being 0.1. So I'll need some calculator help on that one. 2 to the 0.1 minus 1 all over 0.1. By the way, back to the original limit, can we just plug in 0 and expect to get an answer? What's the indicator that we don't get an answer, that method's not going to work?
Can't put 0 in the denominator.
Well, you can't put 0 in the denominator. What about the numerator?
Can't have 0.
It's another 0, isn't it? Don't we get 0 over 0? Which means try another method. We don't have an answer yet. Okay? What do we get here? 2 to the 0.1 minus 1 all over 0.1.
0.718.
All right, let's get a little closer to 0. Now x is 0.01. Somebody run that through your machine and see what you get.
0.696.
0.696.
Yeah.
Probably 0.693, maybe.
Yeah, it's 0.693.
Anybody recognize that? Punch in the natural log of 2 and see what you get. That it? So if we did this exactly, the answer to this would be the natural log of 2. I mean, we're not expected to know that, but we are getting a value that is getting closer and closer and closer to the natural log of 2 as x approaches 0. So eventually we'll develop this derivative method in this course, and you'll see that it's the natural log of 2 in this case. Okay, just let me know right now. We don't have the time to do it today, but are there other questions from 2.2? Anything that we're holding over there?
2.3.
2.3? Okay, we'll have time for that. I'm not going to make any new assignment today, so the same assignment from 2.3, just carry that over. All right, that'll finish this up.
To open my homework sheet. It says my name is not in the list.